Okay, let's add one more. Let's add one more point to this, and let's call this PQR. Let's do this S. S of x equals, and instead of picking a specific number, I'm going to pick A. Let's add a slider there. A times 4 to the x. And so it looks like as I'm changing my A value, I want to see if I make this. There we go. So my A value is actually, it's still going up at about the same rate, right? But it looks like it's crossing the vertical axis in different places. So I'm actually going to graph one more thing. I'm going to graph the point 0, comma A to show you that, let's label that too, to show you that whatever my A value is, you can see that point is actually tracking along with the graph, because as my A value increases, that's where it's crossing the vertical axis, is at 0, whatever that number was. So just like we had earlier when we had 10 times 4 to the 0, when this number is 0, that's going to make this term 1, which means your value of the function is going to be just whatever that number was before it. So if we turn this into like this expression where we have a times b to the x, a times b to the x, if we think about what would happen, I'm going to do it over here since there's more space. If we have a times b to the x, then if we imagine what happens when x is 0, then this is going to be a times b to the 0. B to the 0 is 1, so this is a times 1, which is just a. So whenever we have an x value of 0, our value of the function is a. So this point is going to always show up on the graph. So we can write this out and summarize what we talked about by saying it's changing the vertical intercept.